Alright, in this video I will show you how to do exercise 5.53, and which reads, one problem for humans living in outer space is that they are apparently weightless. One way around this problem is to design a space station that spins about its center at a constant rate. This creates artificial gravity at the outside rim of the station. You may want to review page. Alright, so part A says if the diameter of the space station is 740 meters, how many revolutions per minute are needed for the artificial gravity acceleration? So first of all, I first figured out the radius, which is just the diameter divided by 2. So 740 divided by 2 is 370. And we know that g is going to equal 9.8 meters per second squared. So from there, we know that we have to use this equation in order to find the amount of time it takes for one revolution, which is t. So we use a rad equals 4 pi squared r over t squared, and we solve that, or we rearrange the equation to make it solve for t. So right there for t, we have the square root of 4 pi squared r over g, and from there we can input the radius as well as the g, which is square root of 4 pi squared times 370 meters, the radius, over 9.8 meters per second squared, which will equal 38.6 revolutions per second. No, well, And then it's asking for revolutions per minute. So we'd have to simplify the 38.6 seconds and divide 60 seconds by 38.6 seconds in order to find the minutes, which ends up being 1.55 revolutions per minute. And then we move to part B. And part B reads, if the space station is a waiting area for travelers going to Mars, it might be desirable to simulate acceleration due to gravity on the Martian surface, which is 3.7 meters per second squared. How many revolutions per minute are needed in this case? So instead of using g, which was 9.8 meters per second squared, we are going to substitute that g with 3.7 meters per second squared. We're still going to use the same equation that we did, and we already have it solved for t as we did in part A. So from there, we just input the same numbers aside from the g, which is right here, which we substitute that with 3.7 meters per second squared. So it reads square root of 4 pi squared 370 meters over 3.7 meters per second squared, which gives us 62.8 revolutions. Okay. And then once again, it's asking for revolutions in a minute, which we use the exact same way by dividing 60 seconds by 62.8 seconds to equal the revolutions per minute, which is 0.955 revolutions per minute. Thank you.